Hello everyone, I am Venkatanantiyal, a second year student at Sri Venkateswara College of Engineering, Bangalore. In this video, we'll be exploring about the memory unit design with file system simulation and tree-based storage projects. So before diving into the video, let me introduce my crew mates, that is Ranjit, Rahul and Pawan. So introduction part will be handled by Pawan Gowda, and let's dive into the video.
Let me go to the introduction part. This project brings together core principles of operating systems, data structures and computer organization, and an article to create a function and efficient file system simulator. In this we have primary objectives: the dynamic memory allocation to manage storage efficiently, tree-based hierarchical storage binary directory structures in modern operating system, the fundamental file operations including create, delete, append and search functionalities. And we have implementation of data structure. In the implementation of data structure, we have task structure, task queue, which is FIFO, task management and efficiency. Task structure, we have the task structure used to manage file operators, which is create, append and delete. Fields, operation types, create, append, delete, and name, file name and additional data for append operations. Task queue, queue or array used to store tasks in order, ensures tasks or procedures in the order they are received. Task management. Tasks are added to queue using add task and processed subsequently using process task. Efficiently. Data structure held in efficient task scheduling and memory management by organizing task and file operators. Implementation of operation system. This will be done by Rahul.
Of operating system. Today we will be looking at several functions that interact with the file system in C environment. First function is delete file. This function is used to delete the file specified by a variable file name. Here, if remove file name is equal to 0, here the remove function is used to delete the files. It takes the file name as its argument. If the statement is true, then it prints the printf statement, file deleted successfully, else it throws an error. The second function is display files from the system. Here this function iterates to the files and directories within the current directory and prints their names to the console. Directory is equal to open directory. This line opens the current directory using the open directory function. The result is stored in a directory stream variable named directory. While loop. Enter is equal to read directory not equal to null. This loop continues as long as there are more entries to read in a directory. Each iteration, read directory reads the entry in the directory and stores it in a entry variable. Here the if statement checks if the current entry is not special entities representing the current directory or the representing the parent directory. If the condition is true, it prints the name of the current file or the directory to the console. After the loop is finished, the line closes the directory stream using close directory. The third function is process task. This function iterates to the queue of tasks and executes each task. The tasks are assumed to be stored in an array called task queue and their count is stored in a variable task count. For loop, this loop iterates over each task in a queue. The loop variable I starts at 0 and increments until it reaches the task, which is the number of tasks in a queue. Inside the loop, the line prints the details of the current task to the console. It prints the task I plus 1, the operation to be performed, a task queue of I dot operation and the file associated with the task. Task is equal to 0. After the loop completes, the line sets the task to 0. This effectively clears the task queue, indicating that all the tasks have been processed. Fourth function is create file. This function attempts to create a new file. Here, this line opens the files with the specified file name in a write mode. If the file is opened successfully, then a file pointer is returned. If the file cannot be opened, it returns the null. If statement checks if the file was opened successfully. If it was opened successfully, this line closes the file using the fclose function. Use memory plus is equal to size. This line updates the use memory variable, perceivably to create a track of total memory used by the program. The size variable represents the size of newly created file. Here, this line calculates the free memory by separating the used memory from the total memory. Then, if the file was created successfully, this line prints the success message to the console. This line calls a function name called add task to add a newly created file to the task queue. The argument passed to the add task indicates that this is a create operation on a specified file name. Else the file could not be opened, then the else block prints an error message to the console. Now the fifth function is append to file. This function appends the data to an existing file. The line opens the file with the specified file name in append mode. If the file is successfully opened, the file pointer is returned. If the file cannot be opened, it returns the null. If statement checks if the file was opened successfully. Then here, if the file was opened successfully, then the line prints the data to the file. Data is the data to be returned. Size of char is the size of each element in the data. String length data is the number of characters in the data. File is a file pointer, and this line closes the file using the fclose function. File management stimulates the file operation, create, append, and delete files, keeps track of memory used for files, and ensures a proper file management. Task scheduler uses a queue to schedule and process tasks sequentially. FIFO mimics an OS task scheduler that processes the task one by one. Memory management track total memory, used memory, and free memory. Simulates OS memory management by adjusting the memory usage when files are created or data is appended. Implementation of Ddco. Here the code stimulates a memory management by tracking the total memory, used memory, and free memory. It includes a function to display the current memory usages. Here we are declaring three variables, that is total memory, used memory, free memory. And the total memory is initialized to 1624 bytes, which represents the total memory available. Used memory is initialized to 0, indicating that no memory has been used yet. And free memory is initialized to 1624, which is initialized as same to the total memory. And now we are creating a function called display memory usage. This function brings the current memory usage statics to the console. It prints the header for the memory usage output, then prints the total memory, then the amount of memory currently in use, and the amount of free memory. Now then we are creating another function, create file. This function used to create a new file and updates the simulated memory usage accordingly. Here the user enters the amount of memory required for the file in bytes. Then the user input for the required memory size and it is stored in size variable. Next we are trying to open the file with the specified file name in read write mode. If the file pointer is returned successfully, then otherwise it returns null. If a file is not equal to null, it checks the file was opened successfully. Then the file is closed. If it was opened, then the used memory is added by the size of the newly created file. Then the free memory is calculated by subtracting the used memory from the total memory. And then it prints the success message to the console indicating that the file has been created successfully. The file and data storage simulates the storage and management of files analogs to disk storage management in real OS. Memory addressing manages the memory allocation and tracks used versus free memory for file storage. Task queue as a hardware queue. The task queue is software level representation of hardware level task scheduler for the instructions queue. Sequential task processing mimics the CPU task processing where tasks are executed one after the other, ensuring a proper sequence.
This project offers the functionalities such as creating files, appending data, deleting files, displaying memory usage, listing files in the directory, processing a logged task, and searching for a specific file. It also maintains a task queue to log the operations which is being performed. And the program starts by defining a structure called task, which is used to store the information about each operation, and this includes the operation type like create, append, and deleting the file, and the file name being acted upon, and any data being associated with the operation such as data which is being appended. And there is a global task queue that is used to define an array which is used to store 10 tasks, and along with that we have task counter which keeps on the track of the tasks which is being added to that. And then for simulation there are three global variables, that is total memory, use memory, and then free memory. So use memory tracks how much memory is being allocated, and the free memory which is the remaining available memory. So these variables simulate resource allocation for creation and deleting of the file. So this is the function declarations. These all are the function declarations, and then we have a function called add task. So this particular function is used to add operations in the task queue. It takes the operation type, file name, and optional data as input and stores the information in the task queue array. These actions are recorded for the later review. And then we have creating file. So file creation. So this function allows you to create a file by specifying its name and then memory required. So it creates an empty file using the fopen function and updates the memory usage. And then if the file is being created successfully, the operation is logged out in the task queue. Then we have append to file. So append to file function allows the user to append the data in an existing file. The user provides the file name and the data which is being appended to that file. The file is opened in append mode using fopen, and then the data is written into that. This operation is also logged in a task queue. Then we have deletion of the file. This function allows the removal of the file, that is to delete the specified file. If successful, the operation is logged and the memory usage could be updated if, in a more advanced implementation. Then we have display from files from the system. So we have display files from the system, display files from the system, display all the files in the current directory. So it displays all the file from the current directory, that is displays file from the system, uses the open dir and read dir functions to iterate over this file in a current directory, skipping special entries like dot and triple dots. And then we have display memory usage function. Memory usage is being tracked and displayed using this function, which allows which prints the total used and free memory values, and this provides a clear overview of the resource utilization. Then we have process task function. So process task function, it displays all the log tasks in a task queue, and it iterates through the task queue array and prints each operation along with any associated data after processing the task queue is being cleared. Then search file. So this function allows the user to check if the specified file exists in the directory or not. If found, the program opens the file, reads its content and displays the content. And then this is the final part, that is the main function, which runs an infinite loop providing a menu of options for the user. Depending upon the choice, it calls a particular function which is being put by the user. And the loop continues until user selects the exit option. At each point, the program terminates. Output part is being explained by Ranjit.
I am going to explain the output of the code which Venkat has explained. First, for this code, I want to create a file. So I am selecting option 1 to create a file. I will give the file name as ranjit.txt. Now the file is created, and now I need to enter the memory record for this file. I will give some random of 15 bytes. So the file is successfully created. I will check whether the file is created or not. The file is created. Now I will append something data to the ranjit.txt file. I will select second option to append. I will select ranjit.txt. Now I will enter the data. Hello. The data is appended to that file. I will check whether the data is appended or not. The data is appended, and now I will give something data in this file. Whether I will check whether the data is implemented in the output or not. Now I will create a file in the outside the program. Then I will check whether it is implemented while I am checking the files in the code. I will create a new file here called Venkat. I will try to insert data by this code. I will select option 2 to append a file. I will select venkat.txt. If it is present, it will show append data. So the venkat.txt file is present. So I will enter the data. I will check the files that is present in the directory. So I will select option 4. See, ranjit.txt, venkat.txt both are present in the directory, and remaining these files it is showing. Now I will check the memory that is used by this code, not by the files which is present in the file manager. We are given 15 bytes to the Ranjit file, so it is only tracked, the memory is only tracked by which are the files created by this output, not by the file which is created outside the program. It is calculated only the file created in the program. Now I will search the files. I will search the files to see the content what are present in the file or not. I will select 7 to search the contents in the file. 7. I will select the Ranjit because I have entered something. I entered the content by the manually, not by the code. So I will check whether that content is visible here or not. Ranjit.txt. See, I am Ranjit in manually outside the program, not in the program. It is implemented here. It is visible by this code also. Now I will select Venkat file. I have entered I here, so it is displayed. I have entered I here, so it is only displayed here. I have not entered manually here, so it is only I. Here, hello, I am Ranjit. So it is working properly. Now I need to check the process which is done by the process tasks. It is queue. I have implemented queue first in first out, we will check whether it is working properly or not. First we created Ranjit file and we appended the yellow in ranjit.txt, and we appended venkat.txt in the file venkat.txt. We are not created venkat.txt by this program. We are appending appending I in venkat.txt. We created ranjit.txt and appended. We only appended for the venkat, not created, because we created the file in manually. So it is not showing because it is only available for the program creating file or appending, not by the outside the program. Now we will delete the files ranjit.txt. The file is deleted. Now we'll check what are the files present in the directory. See, ranjit.txt is not present, and here also ranjit file is not present. Now I will also delete venkat file. Venkat.txt file also deleted. I will check the directory which is present or not. It is over. Now finally I will display the process tasks now which are done. We have only deleted ranjit.txt and venkat.txt. Finally the program is over. I can exit. Thank you. This is the project we have done.